All right, so she give me a little recording notice here. All right, so today we are going to do a very short lesson, kind of wrapping up the content and kind of putting it all together. Again, the idea is that on Friday we will have our quiz, hopefully. No. So we talked about stars in general, and um, then we talked about our sun, and then we talked about star life cycle. So this is going to kind of bring it all together here. Then we're we were talking about nuclear equation, making the elements and stuff last, you know, Friday and on Monday. From here, we are going to kind of talk about the death of a star, and then how new things come from stars, because that's where we're going to be going next week. Next week, we're going to be talking about how Earth was formed and how our solar system was formed. And again, our solar system and Earth is formed from stars in the past. So, again, not a whole lot we're going to cover today, just a couple of minutes. So, remember that as stars run out of fuel, okay, because they're doing nuclear fusion, that is the fuel that they're using. They're taking that hydrogen that makes up stars, and then as they burn through that hydrogen, they will start to expand to counteract gravity. Okay? And what they're doing is they're decreasing their density. They're changing their density so that gravity doesn't keep pushing on them. And the easiest way to change your gravity is to get bigger, is to get wider. Okay. As you get wider, gravity will start to kind of, for lack of a better word, gravity will kind of spread out, and you'll have lesser gravity. Okay. Not really the best word to use there, but the distance changes, and so the force of gravity gets smaller. Okay. So they were either then continue to expand and dissipate their matter, and along with all the elements that they made, it will dissipate it, and basically what that means is just kind of spread it out. Okay. And that will create a new dusty area, a new cloud of dust of materials, and we call that the nebula, remember? But this is going to be called a planetary nebula because it made other elements. It's not just hydrogen gases. Now it's helium and lithium and beryllium and whatever elements that it was making in this process. Okay, and so we call it a planetary nebula. Any hydrogen that is left over could become a new smaller cloud or star. Okay, but the other elements that were made from the previous star could turn into planets and asteroids and comets that have different ingredients than stars. Okay. Earth is a rocky planet, and we're going to talk about why the first couple planets on the solar system are rocky, and the outer planets in the solar system are gas planets. We're going to talk about that probably next week. And but Earth is made up of different elements than what a star is made up of. And so that accumulation of gravity condensing that material together creates different bodies, different celestial bodies. So instead of making a star, it can make a planet, it can make asteroids, comets, meteors, etc. All that other stuff that's in the solar system. And again, those elements came from a previous star, not the star that's there today. So our sun today did not make the ingredient for our planet and solar system. A previous star made those ingredients and then made our sun, and then those ingredients are all orbiting around our sun, that star. Or the other option is that gravity will win over the expansion, causing the star to revert back to a dwarf star, put pressure, put pressure, put pressure, put pressure. That process of sudden shrinking could lead to a supernova. So again, where the star just pressure, 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 and it wants to pop and explode, or it could pressure, 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 and collapse itself into a black hole. Okay. And again, eventually, when a star reaches a dwarf state, that's done. It's not really going to do anything anymore. It doesn't have a lot of temperature. It doesn't have a lot of nuclear energy. It's pretty much done at that point. Gravity kind of won, and that's kind of the end of the cycle. Is when it reaches the dwarf star or when it reaches a black hole. The supernova is just another, it's going to create another nebula as a result of a supernova. And so that can restart the cycle again and again. Okay. So remember that supernova is a massive release of energy that could fuse even more protons together, forming very large elements in the atom. This also spits out all the elements and matter into the area, surrounding area, which creates another planetary nebula. Okay. All right, so the stars are either going to create nebula, go back into a nebula, or they're going to end up collapsing and turning into a dwarf star or a black hole, and then that's the end of that life. So to wrap it all up, the Big Bang Theory states that the universe began as nothing, and then as it expanded, the energy turned into the building blocks of matter. Okay, it didn't create hydrogen and helium yet. Those building blocks of matter, the protons, neutrons, quarks, all those little guys, the building blocks of matter, later formed the first small elements such as hydrogen and helium, maybe a little bit of lithium, beryllium, but mostly hydrogen and helium. Gravity brought that hydrogen together to form the massive stars. Sorry, my dogs are going to start barking here. The small stars make helium because that's all the gravitational force they have. The medium mass stars we say to make up the carbon or oxygen, and then the large stars can make up the element up to iron. Okay, so again, iron being 26 protons. As stars die, the gravity can make them condense, pressure, and then that can make larger stars there. 1 second, let me tell my dog barking. Sorry, my dog is barking like crazy. All right, so anyways, gravity, so again, as the supernova condenses a star, that can force more and more protons together, and the largest naturally occurring is 92 protons, that's uranium. And again, you guys might go off and find out that, wait, 93 is naturally occurring, 95 is naturally occurring, okay, and we'll change what we think about stars and what they can do, okay? But that is just what we have today, right now, okay? So the stars turning into planetary nebulas, spewing out all the new element, can create new celestial bodies, including things like planet Earth. All the elements from planet Earth came from previous, now gone stars. Therefore, everything on Earth is essentially star dust. It's the remains of a previous star. Okay. And so this is essentially how the universe made everything. Even us. We are the leftovers processes of the nuclear furnaces in stars, and the stars made up carbon, and they made oxygen, they made phosphorus and nitrogen, all those elements that we are today. Okay. All right. We're not really gonna go into breakout group today, mainly because today's activity is a video. You guys probably don't need to do a breakout group. You guys just watch the video. The video is about 10 minutes, and then I'm going to ask you to summarize it. Give me a good summary. I do like this TED Talk video. The presenter does a really good job talking about light years. Not really something we've talked about very much. But the video will talk about it, and she does a good job talking about light years. She does a good job talking a little about the Big Bang and then the process of stars making elements. So I really like that video. So on your handout that we were looking at yesterday, at the bottom of it, there is activity D or activity E at the very bottom, and that is a video called "We Are Dead Stars." This is Dr. Thaler, and basically, kind of summarize what she said in her TED Talk video. Okay? That is it for me today. When you finish that assignment, especially if I talked to you yesterday, if you finish that assignment, please work on any missing grades, any missing work that you have. Please work on getting that turned in. You know, so again, use your time wisely when you finish that video. Okay, pretty short lesson for today. Okay, watch that video, turn that assignment in when you're done, and then we'll get ready for a Friday quiz on Friday. Okay. So if you guys have questions, just ask me. Okay, I'm going to stop recording for kids that are absent.